Structure, tectonics, and surface weathering play a vital role over the geologic time, forming a passage for the hydrothermal flow of mineralized fluids, accumulating and concentrating the variable minerals at suitable locations and remobilizing and reorienting them as a post-genetic activity. Generally, residual and placer deposits are considered undeformed. However, the majority of other deposits show varying degrees of deformation, whether contemporaneous with their formation or afterwards. Joints and fractures caused by tectonic stresses are breaks in the rocks along which little or no movement occurs. The mineralization often concentrates along these regular or irregular planes, directed compression of the crust, resulting in a semi-plastic deformation creates faults. Usually, fault closures, limb influx zones, and axial planes are suitable for economic mineral concentrations. Joints and fractures along which noticeable movements occur are called faults, or deposits can be faulted with displacement from millimeters to kilometers. Faults are important when it comes to ore deposit formation, as they serve as pathways for the mineralized fluids to pass through, and quite often fault zones act as traps for economic minerals. Shear zones are the outcome of a strike-slip sort of deformation that creates structures like intense foliation and microfolding. A shear zone is actually a zone of distributed shearing in a crushed rock mass with width varying from centimeters to several kilometers. The interconnected openings of a shear zone represent excellent channel ways for mineral-bearing solutions, and subsequently ore deposits are formed. The term breccia is commonly used for sedimentary rocks composed of large, sharp-angled fragments embedded in a fine-grained matrix of smaller particles or mineral cement. Breccia generated by faulting, magmatic intrusions, and similar forces are called tectonic breccia. Tectonic breccia zones are represented by rubbles or shattered or crushed rock masses. Igneous flow or pyroclastic breccia are rocks composed of angular fragments of pre-existing igneous rocks of pyroclastic debris ejected by a volcanic blast or pyroclastic flow. Breccia and conglomerate are similar rocks with difference in shape of the larger particles due to transportation. In the case of conglomerate, tectonic breccias, especially those related to intrusions, can affect pre-existing rocks hosting the mineralization. Moreover, some ore deposits are hosted by many types of tectonic breccia, like volcanoclastic and fault-related breccia. Subduction is the process of two tectonic plates converging. Plates of continental margin arcs, oceanic lithosphere, and volcanic island arcs collide, and one slides under the other. In the process, the heavier oceanic crust stoops under the lighter continental crust or the volcanic island arc, forming a subduction zone. The formation of a subduction zone is closely associated with multidimensional tectonic activities like shallow and deep focus earthquakes, melting of the upper part of the mantle, therefore the rising of magma to form volcanic arcs, plutonic rocks of aphyolite suites, platinum chromium bearing peridotite, donite, gabbro, etc., movement of metal bearing hydrothermal solutions, and metamorphic dewatering of the crust. The great belt of porphyry copper gold that extends north from central Chile into Peru is a good example that is related to the subduction of the Pacific Ocean floor beneath the South American plate.